Hi everyone, we'll solve the second worksheet today. So first question is about again the composition. Here we have three functions f, g and h. So how do we find these compositions? So let's start with this one. So we need to have compute this. So what's f of x? It's 4x minus 1. So we put there 4x minus 1. Now we need to compute g of 4x minus 1. So when we see x, we will write 4x minus 1. So here we have the definition of g. We have 4x minus 1 squared. Okay, here we have plus 1. Thus, if we write this one clearly, we have this at the end. So what's h of this? H is defined by e to the x. So we have e to the this polynomial, okay? And for the second function, for the second composition, we have this g of x. We know it's x squared plus 1, so we put there here x squared plus 1. Now we need to compute h of x squared plus 1. H is defined by this e to the x. So when we see x, we will write x squared plus 1. We get e to the x squared plus 1. Now what's f? It's 4x minus 1. So we get 4 e to the x squared plus 1 minus 1. Okay. Now we compute the inverses of the given functions. So we have this function x to the 3 plus 6. Now first we write it in this form, okay? Then isolate x from this equation, okay? Now let's first isolate x. So we have here y minus 6 equals to x to the 3. Now if we isolate x, we obtain this equality. Now to write the inverse of the given function, we write x instead of y and write it as the inverse of the function. So we have this. Okay. So again, we do the same thing. We write it as in this form first, then isolate x from this equality. So here we have 4 minus x times y equals to 1 plus 9x. Now we have, if we distribute y here and get this equality, now we have 4y minus 1, here 1 is coming from there, 4y minus 1 equals to, here we have, if we write this on the right of the equality, we get xy plus 9x, and in the parenthesis of x, we get y plus 9. So as we want to isolate x, we divide the equality by y plus 9 and get this equality. So what's the inverse of the given function? Instead of y, we write x and get the inverse. Now, this third question will contain the basic functions, the functions you need to know already, okay? And in the fourth question, we will sketch the graphs of the given functions by using these ones in the third question, okay? So how do we sketch this function? So we know it's defined by this, right? When x is greater than 0 or equal to 0, it gets x. Otherwise, it gets minus x, okay? When we put 1 here, we get 1. When we put minus 1, we get again 1, so it's minus x. How do we sketch it? So it's basically two lines. On the right of the y line, we have y equals to x, and here we have y equals to minus x, the line y equals to minus x, okay? Another function you need to know is e to the x. So it gets 1 when we put x equals to 0, okay? And it looks like this. You need to know these ones, okay? These are the foundations to sketch a graph of the given function. Okay, now we have ln of x. So its domain, remember, it's positive real numbers, okay, from 0 to the infinity. We have this interval. Okay, and it gets 0 when we put x equals to 1. Okay, so its graph is like this. Okay, these ones you should know. I noted them. Okay, you already need to know them. Okay, so x to the 3 is this. I couldn't sketch it clearly, but so this. So it's like this. Okay, ignore these ones. Okay, it's symmetric to this line. Okay, according to this line. So when you put 1, you get 1. When you put -1, you get -1, right? As the definition of the function is this. And cosinus and sinus. So again, you need to know. So cosinus x is this one because, you know, cosinus 0 is 1. Okay, as in here, when we put 0, we get 1 on the graph of the cosinus. And cosinus kp for any integer, okay, kp, it gets -1. So here, as we have here, okay, not every integer, but for the odd integers. So if it's odd, okay, we get -1 as in here and here. And if it's even, cosinus k pi will be 1. It's even, okay, as in here and here. So this is the graph of cosinus x, okay, of f. Now what about sinus x? So sinus 0 is 0, and sinus k pi, it's always 0 for any integer, okay, as in here, here, there, right? For any integer, okay, here we have 1, 2, 3. For any integer, k pi, sinus k pi is equal to 0, okay, and it gets 1 on at the point pi over 2, okay, and -1 at the point 3 pi over 2, okay. So this is the graph of sinus x. You should know these ones again. Okay, another function is 1 over x. So its domain is all real numbers except 0, as I denoted here. Okay, and its graph is these red curves. What about x squared and x to the 4th? So here we have, for example, for 2, the point 2, we can compute the values of the functions. F of 2 is 2 to the 2, which is 4. And g of 2 is 2 to the 4, which is 16, as in here, okay? So again, for -2, they get the same values. So this green one is the function g, okay? And this is the function f. Now we will use the previous graphs, okay, as in there, okay, to find the graph of the given functions. So here we're given this g, x minus 1 to the 3, okay? The function that we know better is x to the 3, okay, before we solve that, okay? So let's compute a few values of the function f and g at the same points to see clearly what happens when we change it to this function. F of 0 is 0 here by definition of the function, while the value of g on 0 is -1, right? We put x equals to 0 and we get -1 to the 3, we get -1. What about 1? Here we have 1, and here we have 0. 1 minus 1 to the 3, we get 0. So what do we need to do? Here we have -1, so we need to shift the graph of this function to the right for 1 unit to get the graph of g, okay, as in here. So you see, we had this one before. It looked like this. Now we shifted it to the right 1 unit and get this, which is the graph of this function g. Okay,